Okay, good morning. I will be recording this lesson. So you see that we have a lot of empty seats today with the delay in the weather. So this is a little bit of review to prepare us for the next unit, Unit 5, which is on graphing parabolas. So we're going to do some discussion on basic graphing. We'll go into some absolute value functions, stuff like that. That'll be similar. And then we're going to also show you on Wednesday how to do the graphing in the graphing calculator. It's a big benefit to actually know how to use that tool. Anybody who does woodworking, you'll know it's a lot easier if you have an electric drill. Swap out the tip, put the screwdriver tip on the top, and drive that screw right in instead of doing all that stuff by hand, right? So we're going to figure out how to use that tool to help us out. So if everybody has the notes, we're starting right out on day 1. There is a homework packet that goes with it as well to practice. So a point is a coordinate XY pair. Can't graph in 3 dimensions, we can only graph in 2. Okay, so flat paper, X goes side to side, Y up and down on your paper. Remember, the origin is the point 0, 0. Positive X goes to the right, negative X goes to the left, positive Y goes up, negative Y goes down. A linear equation is of the form f of x or y equals mx plus b. You'll notice here, the highest power of my variable is 1. So it won't curve. B is your y-intercept, the place where that line crosses the y-axis. And m is your slope. M is also the change in y, or rise, over the change in x, or run. Change in y could also be y2 minus y1. Change in x, x2 minus x1. Make sure that you have a single point, x1, y1, lined up underneath of itself. Don't flip them. Don't have y2 minus y1 over x1 minus x2. You want to have them lined up appropriately. So that slope m we just talked about represents the change, okay, the ratio at which when I go 1 to the right, how much do I go up? If I go uphill from left to right, that is a positive slope. If I go downhill from left to right, that is a negative slope. The y-intercept is where the line crosses the y-axis, or where I should just say generically, where our graph crosses the y-axis. Or you could also say it's where x equals 0. Anywhere on this y-axis that passes through the origin, the x value left to right is 0. Thank you. Sorry, I gotta put my glasses on. Let me not hear. Okay. Absolute value equation. Y equals A times the absolute value, x minus h, close the absolute value, plus K. Some notes about the absolute value. The vertex, which we'll talk about in a moment, is H, comma, K. H moves your vertex left or right from the origin. K moves your vertex up and down from the origin. Notice it's always X minus H. The other way of thinking about where our X value of our vertex is by taking whatever is inside of the absolute value and set it equal to 0 and figure out what value X makes that 0. Because 0 isn't left or right of the vertex. It would be on the vertex. The vertex is the place where the graph changes direction. So for an absolute value, it is a V shape. If A is positive, it'll open upward. And the vertex is that point right where it stops going downhill and starts going uphill. If A is negative, it will flip the graph over. The vertex, however, is still that point where it changes direction. Only now it's changing from uphill to downhill. A, that value, if it's greater than 1, it'll make it taller and skinnier. It's called a stretch, or if it's less than -1. The absolute value of A is greater than 1. It'll stretch your graph tall and skinny. If it's a fraction less than 1, it'll make it kind of short and wide. It'll spread it out. A minimum or a maximum is at the vertex. It is a minimum if all y values are greater than or equal to that. In other words, it's a minimum at the vertex. All my other y values are above here. So my range would go from the vertex up. If it is a max, all y values or all outputs of my function will be less than or equal to that value. Questions on the definitions? Absolute value functions, by the way, we're talking about because the shape is a V. It's very similar to when we get into parabolas, their shape will be a U. They also have a vertex. A line, a linear equation, doesn't have a vertex because it doesn't change direction. Graphing the following points on a coordinate plane. First, we can label our axes, x and y, or x and f of x. In other words, input, function output. Again, as x goes to the right from the origin, the point in the middle is the origin, 0, 0. To the right, it'll be positive. To the left, it'll be negative. For y, above the origin will be positive. Below the above the origin will be positive. Below the origin will be negative. So here we have the point 3, 4. No sign, so they're both positive. So x is 3, 1, 2, 3. Y is 4, go up 4, 1, 2, 3, 4. Negative 2, 4. X is negative, so we go left from the origin 2, 1, 2. And then y is still 4. Couple more points. Number 3, 1, 5. So we'll go right 1, up 5. 1, 1, 2, 3, 4, 5. Negative 3, 1. Negative 3, -1. So now we're not just going to go left, 1, 2, 3 for X. We're also going to go down 1 for Y. And the last point there on our list, 0, comma, -2. X is 0 anywhere on the origin. In this particular case, we're looking for the point 0, comma, -2, or 2 below the origin for Y. We'll do a little practice graphing as well. When we go to graph linear functions on the coordinate plane, the first thing we can do is identify our y-intercept. In this case, our y-intercept is at y equals -1, or you could say it is the point 0, comma, -1. Your y-intercept is always the value on the y-axis, which is when x equals 0. So we'll plot that first. And then we're going to apply our slope. There's no number in front of x, so you don't call her just your x. She's your 1x, but you don't call her 1x. She's just your x. So my slope here is 1. That means for every 1 I go over, I go up 1. Over 1, up 1. Over 1, up 1. Over 1, up 1. I always plot the y-intercept first to give me that place to start from where I'm going to go over and up from. Now I have enough dots for a line. Well, I'm not going to try to use the line tool. I'll just fill it in. And remember, lines go on forever. So we'll go ahead and put arrowheads on both ends. This is in the form y equals mx plus b, graphing form. If it's not already in that form, find a way to get it into that form by isolating y on one side of your equation. Have a coefficient in front of x and a number at the end. Number 7, first thing I could find is my y-intercept. I set x equal to 0, y equals +2. Or I could say it's the point 0, comma 2. Now I have a slope in front of x. My slope equals -2. That means for every 1 I go over, I'm going to go down 2. Remember, slope equals y2 minus y1 over x2 minus x1. So I just say that this difference is 1. That tells me how much this changes. y2, 0, minus y1, 2 is -2. So -2 over 1. -2 over 1. -2 over 1. -2 over 1. Draw my line. It doesn't just go to the right, it also goes to the left. If I was trying to get my slope over here, I'd have left 1 up 2. +2 over -1 is also -2. Questions on 7. For some of you, this is going to seem very basic. For some of you, this is going to be a very necessary refresher. Okay. For all of you, it's 32 minutes, a chance to kind of get ready for what's coming next. Y equals 1/3 x. First things first, the y-intercept. Sophia, what is my y-intercept for this one? 0. You don't say it. 0 it is. Or you could say, if I set x equal to 0, what is y? 1/3 of 0 is 0. It's also the point 0, comma 0. X equals 0. When I put 0 in for x, y equals 0. So there's.
How did that happen?
I don't know. You had your phone on. There is my slope. My slope equals 1/3. 1 +1/3. So I can go up 1/3 to the right. Up 1/3 to the right and connect my dots. On number 1, positive slope, uphill from left to right. Number 2, negative slope, downhill from left to right. Number 8, positive slope, uphill from left to right. Good thing to check. The other thing you can do when you go to graph these, will be more important on the next part, is you can create a t-table. Call that because it's shaped like the letter T. The first thing I can do is put in my y-intercept when x equals 0, y equals 0. If x equals 1, 1/3 times 1 is 1/3. That's hard to graph. If x equals 2, 2/3, also hard to graph. But when x equals 3, 3 times 1/3 equals 1. So there's a good point to graph. For a linear equation, I only need 2 points. That defines a line. But I also know that I could go back to -3 times 1/3 is -1. So you only need 2 points to define a line, but it's always good to have that third one to make sure you got it right. Graphing absolute value functions. Remember, absolute value functions are of the form y equals some multiplier, a, times x minus h plus k. My vertex will be h, comma, k. That's the point where it changes direction. A will stretch or compress. If it's negative, it'll flip or reflect that graph. So x minus h plus k. Nothing's added on to the end. So k is 0. X minus h, so h is 1. The other way of thinking about this is what value of x would make inside of my absolute value equal to 0? Well, if x minus 1 equals 0, then x equals 1. So x minus 1 shifted my graph 1 to the right. A, well, there's nothing out there, so there's just one of them. It's a positive number, so I know that my graph will open upward. So again, I can do a t-chart. And I know that if it is an absolute value, I'll start from my vertex. I can go left 1, right 1. I should get the same value because it'll be symmetrical. So if I go right 1 from 1, that's 2. Put in 2 for x. 2 minus 1 equals 1. The absolute value of 1 equals 1. 1 plus 0 is 1. Going 1 to the left. 1 to the left of x equals 1 is x equals 0. Put in 0 for x. 0 minus 1 is -1. The absolute value of -1 is +1. +1 plus 1 plus 0 is 1. So here is my graph. So the value at the vertex is a minimum. And at that minimum, it is the point 1, 0, or the minimum value of the graph is y equals 0. If I was doing my range, I would say my range, y is all those values where y is greater than or equal to 0. Number 10, I'm going to put it in the full form. So a is -1 times x minus 0 plus -2. So h is 0. K is -2. That is my vertex. A, my coefficient in front of the absolute value is -1. That means it's going to flip my graph downward. So we'll do a little t-table. If I go 1 to the right, x is 1. The absolute value of 1 is 1. 1 times -1 is -1. -1 minus 2 is -3. If I go to the 1 to the left, x is -1. The absolute value of -1 is +1. Positive 1 times negative 1 is negative 1. Negative 1 minus 2 is negative 3. I see my symmetry, so I know I got my vertex right. Now I can draw my absolute value function. Because that leading coefficient is negative, that vertex value is now a maximum. It is a maximum at the point 0, negative 2. The value of the maximum is y equals negative 2. Question on number 10. 11. Always of the form y equals a 2 times the absolute value of x minus h. So here I have plus 3. That means it's really x minus negative 3. Or I could say x plus 3 equals 0 when x equals negative 3. And then it's plus k plus negative 2. So h, k. My vertex is the point negative 3, negative 2. X is negative 3, 1, 2, 3 left of the origin. Y is negative 2, 2 below the x-axis. Here's my vertex. A, the multiplier, is positive 2. It's still going to open upward, but now every output value is being multiplied by 2. So it's going to become taller and skinnier. So I'll do a t-chart. I'll put my vertex in the middle of my t-chart. Hopefully I got it right. I'll find out when I do the point to the left, point to the right. To the right, 1 to the right of negative 3 is negative 2. I plug that into my equation. Negative 2 plus 3 is positive 1. The absolute value of positive 1 is positive 1. Positive 1 times 2 is positive 2. Positive 2 minus 2 is 0. 1 to the left of my vertex, x will be negative 4. I'll plug in negative 4 for x. Negative 4 plus 3 is negative 1. The absolute value of negative 1 is positive 1. Positive 1 times positive 2 is positive 2. Positive 2 minus 2 is 0. I see my symmetry, so I know I got my vertex right. I plot that point, and I'll draw in my graph. The leading coefficient is positive, so this is a minimum, and it is a minimum at the point negative 3, negative 2, or the minimum value is y equals negative 2. Questions on example 11. All right, so if you go ahead and turn to that homework packet. We're not doing just the odds today. We actually created this specifically for the review. But while you're here, since we only have about another 7 or 8 minutes of class, start out trying out number 1 and number 7, just to make sure you kind of got it before you head out. We are doing them all. We're doing them all. We're just starting. Make sure you do one of each before you head out. So if you have any questions as you're doing it, you can ask.